Let's move on to the next example. So we have the following scenario. It says, well, an industrial company claims that, the mean pH level of the water in a nearby river is 6.8. Okay, the mean. So guys, you have a claim, you have mean, and is 6.8. Okay. You randomly select 39 water samples and measure the pH of each. The sample mean and the sample standard deviation are 6.7 and 0.35. Is it enough evidence to reject the claims of the company when alpha is 5%? Very good. So let's go back to our board and start analyzing this scenario. We need to follow the steps and check to see if the p-value is less than or equals to alpha or not. Very good. What is our first step? Let's take a look at our very first step. Our first step is to construct the null and alternative hypothesis. Step 1. What is my null? What is my alternative? Well, let's get back to the question. The question says, hey, the company claims, there is a claim that the mean is 6.8 is the keyword. So our keyword is It means that we have equality, right? Equality equivalent to x. Since it is equality, it means that your null is given to you. So mean is exactly 6.8. And remember that in this scenario, in this case, your claim and null are the same thing. Very good. So I have the null, the alternative is going to be its opposite. Its complement. Mu is not 6.8. It's either less than or larger than. We don't know which one. But the alternative hypothesis says it's not equal to. Okay, step 2. What is our standardized statistic? Standardized test statistic. Is it z, which is x bar minus mu, divided by sigma times square root of n? Or is it t, x bar minus mu, divided by s times square root of n? Which scenario is this? Let's take a look at the question again. Do we have any information about population standard deviation? No, we only know the sample mean and sample standard deviation. It means that we are dealing with t distribution. So it's not a z. We cannot use a normal CDF. We have to use t and t distribution. T is x bar, which is 6.7, minus mu, which is 6.8, divided by s, which is sample standard deviation, 0.35 times square root of n, and the sample size 39. Well, approximately we get negative 1.78. This is my t. I'm going to use t to find the p-value in the next step. Step 3, find the p-value using t, which is approximately negative 1.78. Very good. Let's take a look at the website. You can use the website or you can use a calculator. Both of them are fine. So if you're using your calculator, let's turn on the calculator, clear this one, go to stat. So let me write this guy down here for you. Stat, go to tests. Okay. And here you're going to select t-test. T-test. Okay, in your t-test, let's see. We don't have the actual data. We have the statistics of the sample. What is the mean? 6.8. 6.8. What is X bar? The sample mean 6.7. What is the sample standard deviation? 0.35. What is N? The sample size 39. And then now you have a two-tailed test. Why is that? Because it says not equal to. When it says not equal to, it means that you have a two-tailed test. It's either on the left or it is on the right. That's why we have a two-tailed test. Two-tailed. Okay. So since I have a two-tailed test, I'm going to select the two-tailed and do the calculation. Let's do the calculation. See what do we have. Well, it says, hey, the p-value for you is about, is it 8%? Yes, the p-value is about 8%. P-value is about 8%. So in the last step, your job is to compare p-value and alpha. Is p-value less than equals to alpha? What was our alpha? Alpha was 5%. P-value is 8%, which is larger than 5%. So p-value is not less than equals to alpha. If it was, you reject the null hypothesis. If not, we say that, hey, we fail to reject support. Interpretation is that we support the null hypothesis. Since null hypothesis and the claim are the same thing, it means that we support the claim. So we support the claim.